you for joining us today. We're going to be talking about delivering high performance applications via using performance testing, also known as pen testing. I want to make sure that everybody gets ready. This is got a couple slides to show here. Today, we are joined by Zoeib Baram and Humayun Tayyib. My name is Judd Halenza, and I will be hosting today's webinar. Today, we're going to be talking about applications performance issues, servicing via QA, and marketing market-ready product. Our outline is a problem statement, our solution for performance testing, what is performance testing and its types and metrics, proposed solutions to client and approach, performance testing tools, detailed reports and recommendations, and how they're applicable, applications comparative analysis, and performance testing best practices and pitfalls. Our problem statement. Rob contacted AlphaBolt because their application was having issues with performance as the user loaded increased at specific modules. What we did. Zoeib, would you like to take over?
Yes, thank you, Mitch. So to resolve the issue, which our client Rob was experiencing, we at AlphaBolt took the following steps. First, we carried out an application analysis. We investigated the physical test environment and the production environment to choose the test tool that would best meet the application's need. Moreover, we decided on the specifics of the hardware, software, and network setups that will be used during testing so that we may design tests that are more specialized and effective. Then we created a user workload pattern in which we first finalized the iterations and then finalized the load of users to put in each iteration. Then after this, we finalized the parameters or the performance matrices to monitor during the testing process. When we perform performance tests on the application, the understanding of performance metrics is very important. So we will talk about this in detail as we will proceed further in this webinar. And afterwards, we finalize the performance testing approach. And once the testing approach was finalized, we overviewed the different tools available. And then after discussion with Rob, we finalized the JMeter, because it was an open source testing tool available, and also because in the future, Rob also wanted us to do the API testing of the application. So by choosing JMeter as a performance test tool, in future, we can also use this test tool to perform API tests on the application. Then afterwards, we performed performance tests on the client's application to identify the performance bottleneck. And then we reported those performance bottlenecks and created a document of recommendations to share with Rob. Next slide, please. Thank you. So in this era of digitalization, there is a fierce marketing competition. Therefore, companies today must ensure that their products are not only enjoyable to use, but also free from any software-related issues, particularly performance issues. Because if your application experiences any performance issues, customer will switch to the competitor's application. And this is where performance testing comes into play, which ensures the stability of the product, which in turn raises and maintains customer happiness and retention. So before digging into the complex details, first, let's have a brief overview of performance testing and why we use it. So we use performance testing to measure how quickly, responsively, and steadily a computer, network, software program, or other device responds to a workload. And the workload in this context refers to the number of users using the application concurrently or who are simultaneously submitting requests to the server. So the organizations conduct performance evaluations to spot performance-related bottlenecks in their application and to measure the stability of the application. Next slide, please. Over to you, Jed. Thank you, Jed. Let's now discuss the different performance testing types that are available. So basically, there are various performance testing types, including load testing, endurance testing, volume testing, scalability testing, spike testing, and stress testing. So to create a customized solution for the issues that Rob was experiencing, we employed load, stress, and endurance testing on the portal. I will now explain these types in depth, and after that, we will have a brief discussion about the other types that are available. So in particular, if we talk about the load testing, it is a performance testing technique that enables us to comprehend how a system will behave under a certain load value. Therefore, during load testing, we basically mimic the anticipated volume of users and transactions over a period of time in order to check the actual response times and identify the performance bottlenecks. Therefore, when we perform load testing for Rob, so we did so for the application specific functionalities such as the checkout card and the site search. And for the bottlenecks that were discovered during this stage, we created a report that showed the application's performance at different user loads and intervals. And now if we talk about stress testing, we use it to check how well the system works above its expected capacity limits. So stress tests allow us to understand our workload scalability, which put a strain on hardware resources to identify the potential breaking point of an application based on the resource usage. While in endurance testing, we evaluate how the software performs with a normal workload over an extended amount of time. Therefore, after performing load testing on Rob's application, we ran stress and endurance test on its checkout card functionality. So basically, the goal was for the functionality to be stable enough to handle the load of 1,700 users for the duration of 30 seconds. So we tested that functionality by increasing the user load to more than 1,700 concurrent users, and we tested the entire functionality in different samples. So we identified the application's breaking point at the conclusion of this phase based on how it performed under the load, and we then produced a report of that, which in turn helped Rob to optimize the application performance. So now, if we discuss the other performance testing types briefly, we have volume testing, in which we determine how efficiently the software performs with large projected amount of data. Scalability testing, that is used to determine if the software is effectively handling increasing workloads. Basically, this can be determined by gradually adding to the user load or data volume while monitoring system performance. And in scalability testing, we also keep the workload same by changing the resources such as CPUs and memory. Whereas in spike testing, we measure how well software performs when workloads are rapidly and repetitively increase significantly. Next slide, please. So
Okay,
here's the poll for you to vote. Yeah.
Yep, another quick poll for everybody. Well, that's kind of interesting. It looks like the majority of people do scalability and stress testing, but we don't see a lot of people doing volume, load, or endurance testing. So kind of an interesting result there. You want to go on to the next slide?
Yeah, sure, please, Ed.
Okay.
Thank you, Jed. So before we talk about the performance testing strategy we utilized and the solution which we proposed to Rob, let's first talk about the performance metrics or KPIs, which are also known as key performance indicators, because they play a very integral part in understanding the performance test. So performance testing metrics are the measures or the parameters gathered during the performance and load testing processes. And with the help of these matrices, we determine the success of the performance testing process. And we further identify the critical areas in the software that needs more attention. So if we talk about the most important performance testing metrics, they are CPU utilization, which is the percentage of CPU capacity utilized in processing the request. Memory utilization, which measures the utilization of the primary memory of the computer while processing any work request. Response time, which is the total time between sending the request and receiving the response. Better the response time, the better the performance of the application is. Average load time, which measures the time taken by a web page to complete the loading process and appear on the user screen. Throughput, which measures the number of transactions an application can handle in a second. Average latency, which is the time spent by a request in a queue before getting processed. Bandwidth, which is the measurement of the volume of data transferred per second. Requests per second, which refers to the number of requests handled by the application per second. Error rate, which is the percentage of requests resulting in errors compared to the total number of requests. And last but not least, transactions passed and failed, which is the percentage of the past failed transactions against the total number of transactions. Thank you, Jed. Next slide, please. Next slide, please. Yes, yes, thank you, Jed. So these KPIs are further divided into two categories, client-side metrics and the server-side metrics. So client-side metrics are used to gauge client performance, whereas server-side metrics gauge server performance. So we will also talk about these metrics when we will be having the discussion on the performance test reports, which we shared with Rob at the end of the performance test cycle. So if we talk about the solution which we proposed to the Rob, next slide, please, Jed. Thank you, Jed. So basically, so far, based on our overview of the performance testing, you should have a comprehensive grasp of the various types of performance testing that are frequently employed and the advantages that can be obtained by running performance test on any application. Now let's discuss the solution that AlphaBolt suggested to the problem statement, which we discussed earlier. So by examining the problem statement, we advised Rob to perform load, stress, and endurance testing at first. As previously mentioned, the tool we advised to Rob was JMeter. So we captured the application responses throughout this round of the performance test using JMeter. And we then shared the performance test reports with Rob, which we will discuss in detail in the reporting section. And we devised this complete solution by following the approach which we designed before executing the performance test on the application, in which we first determined the testing environment. Following that, we determined the performance metrics, those that we just discussed. Finally, we planned and created the performance test based on our research. Then before running the test on the tool we chose, we prepared the environment on the specific tool. Then we carried out the performance testing, and after analyzing the test results and identifying the bottlenecks, we produced a report of our findings. And once the client-side performance-related problems were resolved, we retested, running our planned test once again in the environment, and again sharing our findings with Rob. Next slide, please, Jed. Thank you. So in the previous slide in which we were discussing the test approach, we also discussed the tool we chose in the planning phase. So we have a variety of performance testing tools available in the market to choose from based on the client or project needs. But the most popular performance testing tools for evaluating the performance capabilities of web applications are listed on this slide. So basically both licensed and open source performance testing tools are available. So depending upon the requirements of the project, we select the most appropriate tool. So now I will ask Zohaib to talk about the reports that we create throughout the testing process, followed by a discussion of the procedures we use to conduct performance tests and that what are the typical performance related problems that can affect any application. The floor is all yours, Zohaib.
All right, thank you, Mayu. Next slide, please. All right, so reporting is very important aspect of performance testing because everything that we have done through the tool, it comes out in the end on the reporting section that is presented to clients so that client can make a relevant tweak in the code or the adjustments in server architecture or the diagrams which they have set to prepare the environment. So reporting is important, and there are numerous templates of reporting which is available, but I would here present one which is journalized and which is very effective. So in the summary section, you capture all the details that what the application was intended to do and how you set up the performance testing tool and how you are going to present the solution and getting the total artifacts in the report. So that summarizes in the summary section. User load pattern is the second thing which is very important. And here you define that you have to run your performance test with how much number of users for a specific amount of time. For example, in a first run, you're going to execute your performance test script with 100 users simultaneously, or with the 10 users each ramping up into the system after 5 seconds or so. So this is how you define your user load pattern into the report. The performance test environment summarizes both the server-side details and the client-side details. By the server-side details, I mean that application is hosted on the particular server whose specifications are mentioned in this section. And by the client side is the machine on which you have set up the JMeter or the performance testing tool, or in case the specifications of multiple machines on which you have set up the tool to execute the simultaneously performance testing activity. The performance parameters, as Mayu has told, that we mentioned that we are going to present the report on the following parameters such as response time and the memory utilization, the request per second, and the other key KPIs or key performance indicators which are mentioned here. So request description and linkage. So here we summarize each and every request that has been captured by JMeter. I give the example for further clarification over here. So if you have a login page and you have like buckled up your JMeter tool with the login page, then there would be multiple applications such as hitting the URL, which would redirect us to the login page, then giving the credentials, and then clicking on the login button that will generate multiple requests. And then until you landed on the main page, the number of requests which are generated by the application, those are captured over here. So we present each and every request that has been generated by the tool and for which JMeter has got the response from the server. We list down here so that client can get the clear idea that what are the number of requests and what are the actual requests which are being generated by the application. So if he has to like fine tune the number of requests or find out the repeating request, he can easily get that from this section of the report. I give you an example. For the same client, it was facing the issue in which after clicking on the login, it was not able to land on the main page. And upon analysis, this had been discovered that one request was recursively called into the script. So this is how that request was generating multiple times and it was not stopping. So the performance testing tool helped us mitigate that thing, and we devised the plan that this request has been causing the problem and we should eliminate that. And then the execution results. In that section, we gather different graphs which are generated to the performance test report. And I would be giving an idea about the graphs as well. And also the tables which collect the KPIs, parameters, and other information which has been generated by the tool, which summarizes each and everything into this section. And then there is error list or observations. For example, we hit the system and we get 404. For example, there are like memory utilization related issues for which request was failing with the different error code. We tend to give each and every error detail that we encountered during the script execution in this section, so that client can get the clear idea that these type of errors, which are either related to memory or either related to the response time or somehow request per second parameter, those are listed here. So that they can eliminate those things upon the particular request. And other observations such that we observed that on a particular module, the application was hanging or giving a greater response time, so that its efficiency might be increased by increasing the bandwidth of the connection or by increasing the memory of the server or something like that. We put the observations over here. And in the recommendation section, we give that based on the results or final hypothesis, we give that that you should be enhancing the server memory, or you should be implementing the load balancers to fulfill the enhancements or the stability of the application, or if you need scalability of the application, then you need to put the load balancers, or you need to set up the different architecture which can enable the logging as well as quick response to the multiple users at the same time. So we will now be moving to the details of the graphs. Next slide, please. So these are some of the examples. I'm not going to go into the details of these graphs because we will be explaining that in a tabular form that would be more understandable. But these kind of graphs are collected through different tools. Each and every tool somehow gives these type of graphs in which it would be depicting as the successful transactions. It will add it is as it is time plotted graph. So it tells us that during the execution of the performance test script, at a particular time, the successful transactions were increasing or decreasing or something like that. It will show us the pattern, and also it depicts us the failed transactions and their pattern as well. Next slide, please. And this is hits per second. It is on the server side. So server is getting hit per second. It is also time plotted graph. So it also gives us the results. The server is getting that much hit per second during the execution of our script. Next slide, please. All right, this is the response codes over time. So different types of codes or the responses that has been generated by the server over the elapsed time that has been summarized in this graph. Next slide, please. And this is network input output over time. So the network which is during the execution which is used, so it gives us the details about that. These are relatively complex graphs, and we can add as much as tool is supporting, but we can also don't use these graphs to avoid the complexity, and we come into the tabular form, or we can interpret these graphs. Being a consultant company, we can interpret these graphs and gather the results in a tabular format that would be more easily understandable to the client, and they can make the precise decisions on the basis of those tables. So next slide, please. All right, so these are active threads over time. So if your application is supporting the multiple threads, these are like telling us that these much threads are active. And in the JMeter tool or any performance testing tools, the thread means the number of users which are currently accessing the system. So this is also the time elapsed graphs in which we are depicting that at the start of the execution, there were like it started from the 0 users, but eventually with the ramp up time of a couple of seconds or something like that, the users keep on coming to the system, and at particular time it bear the maximum user load, and then it start eventually decreasing. The script which has been completed the whole thing, like from login module to the logout or visiting any sections of the particular application, whenever the user does complete that thing, it eliminates from the system. And this is how user comes to the system and goes out of the system. So this graph explains that at a particular time, the maximum number of threads were this much time, and it came at this particular time. And then the users started dropping out of the system. Next slide, please. All right, so talking about the client for which we did the performance testing, here is we analyzed each and every graph, and then we summarized the results into the tabular form so that that can be easily understandable to the client. So if we talk about the users, so the range for particular users were 100. So minimum, there was 1 user onto the system, and maximum, there were 24 users parallelly onto the system. The average number of users which remained onto the system at a particular time, that was 11.34. It means that average 11 users remained onto the system all of the time. So this parameter eventually shows us that this application on average supports 11 concurrent users. Request per second So if the server is handling multiple requests per second, so this figure would be greater. This means that server possesses the capability of handling multiple requests at the same time or in a given period of time. So it was ranged as 1, but minimum was 0 and maximum were 47.9. And on average, there were 15 requests per second, which server was capable of handling. Similarly, the average response time, this can be treated in seconds, but mostly this is given in milliseconds. But we have like journalized it into the seconds. So average response time, the minimum was 2.23 seconds and the maximum was 10.36 seconds. This depicts that application was extremely slow, or the server which was set up to host that application was not that much capable to handle this much user load. So the response time was higher in this case, and average response time was 5.89 seconds, you can say. So the kilobytes received per second, this is the server side parameters that the server is capable enough to receive this much kilobytes of information per second. Similarly, errors per second. So if request is onto the server and server is failed to respond uh, that request in a particular amount of time, then that request fails. If we burden the server with multiple requests in a given amount of time, then it goes on to the non-responsive mode and it stops further request processing, and the error code is different. So the request starts to fail. But if we give the minimum or a bare minimum which server supports, then the failures are very less. But if we bombard the server with multiple requests, then the request starts to fail. And this error per second is a very crucial parameter in gauging that whether your application supports multiple users or not. So the pending requests are that which are pending at the server side, and server is busy in responding other requests such that the number of pending requests which server needs to process is piling up. So if the server is slow, then this parameter is going on to the higher side. So these were the parameters which we collected before giving any suggestions or recommendations to the client, and client didn't make any tweak onto its application or something like that. And then we propose a few recommendations which are mentioned in the next slide. So after like we have summarized this table to give the audience the clear idea that how the performance test actually work, and upon spending some time, our consultants came up with many recommendations, out of which couple of them are mentioned here so that the audience can get the idea. So out of that, the server specifications in terms of memory processing speed must be increased. This was of the high importance, because whenever this would be applied, the response time would decrease, the pending request parameter would also decrease, and the request per second would increase eventually. So if feasible, team must apply load balancers to get efficient results. So we have give this parameter a low priority, because if they increase the server specifications, and then there are chances that with the current desired load, they wouldn't be required to enhance or implement the load balancers. But in future, if they want to enhance the existing user load from 1700 to 3400 or 5000 users plus, then they would need to apply the load balancers with the multiple servers, so that the application would be routing the request to different servers based upon the load balancers. Network bandwidth should be increased as it is highly affects the application performance. So again, this was of the high mark because they were using a low internet bandwidth, and that was causing the pipeline to be jammed with the responses, and similarly the application started to fail or to fail to provide the response to the client requests. And then there were certain API calls that can be further fine-tuned as per the shared document that was shared separately with the client, that these are the APIs and they are taking this much time. So you need to fine tune them, which were their custom developed APIs. So they worked on that and it eventually increased the results. And the next slide depicts the enhancements in the results and how they achieved with different parameter. Next slide, please. All right, so from users, now it has reached the maximum of 49 users parallelly, and average users were 19.883, which were previously around 13 users. So it enhanced after they made certain changes, it enhanced and it started to support or going into the right direction. And then the request per second, it was maximum supporting 106.96 requests per second, and the average request also increased to 32 requests per second. Similarly, the average response time, the minimum response time was now 0.02 seconds, which was a marvelous decrease from the previous shown result. And the maximum was 5.22 seconds. And now the user were getting on average 0.2 seconds to get the response from the server. Similarly, KB received per second from the server side had increased as well, and error per seconds have reduced to 0 because with the current benchmarks, they have met the server minimum specifications, the client setup and increased the memory and other parameters. So the error started to vanish. Now the pending requests, they were very less, which reached to the maximum 42, but on average there was 9.56, which was also in collaboration with the request per second or average response time. They were handled within the acceptable time, which was set by the client. So it was nothing to worry, and they through the performance testing, it actually did the X-ray of the application, and it pointed out the faults in the APIs or the application areas which were required to improve in order to support the multiple users. Next slide, please. Now, as we concluded this activity for the client, there are some best practices which I would like to highlight for the audience to get the positive results, or whenever they are trying to implement performance tests in their organization, or they want us to come to find a solution for their performance testing activities. So the best practice is test as early as possible. So this means that whenever you are developing your application, it is recommended to apply performance test at each and every stage of the SDLC. But eventually, when you deploy the code on the pre-production environment, you have to do the performance testing of that particular module, which is stable enough to get the initial results and to get the foresightness of your application with the intended objectives. But if you are developing the APIs which you are going to make the part of that application, then before moving those APIs into the application, you can do the performance testing of those APIs, which would give you the clear indication that this needs to be improved. Similarly, perform the test in environment close to the production. As I have iterated, if you have developed the module that is ready to deploy on the production environment, then you have to deploy that onto the pre-prod environment, which might be UAT, but that should be stable enough that it is supposed to be the replica of the production environment. And then you do the performance testing on that environment to gauge that how this application is going to behave on the production environment. So there should be separate performance testing environment. So if there is continuous deployment on the staging on the UAT environment, then there it is best practice to stage a separate performance testing environment that would be the exact replica of the production environment, and that can give you the actual results and not the hypothetical results for which that would help us in establishing the clear objectives and plan accordingly. Maintain the test environment's consistency. So this means that you have to deploy each and every stable thing onto the performance test environment. There shouldn't be fuzzy code on that environment, or there shouldn't be any checkouts to that particular environment, so that it can be the exact replica of the production environment. So now define baselines for important system functions. such as your application supports the login, or your application supports the checkout or check the cart out, or your application supports the shopping from multiple vendors or something like that, then you have to define that the particular area of your application must sustain the user load of the X users, or they should be able to give the response to each and every users within the 2 seconds, or user can perform other actions within these parameters, or there should be no failures or 0.01% of errors acceptable. You have to define these baselines for your system as early as possible. This would help us in order to devising the best plan for our application. Now, because we have years of experience in performance testing, I also want to highlight the common issues which we face whenever the client is now contacting us to find out that what are the issues into their application. So the common issues which we can come across whenever we perform the performance testing on a particular application is the response time issue. This is of high thing that client expects the particular module to be very less in response time, but actually they are not spending that much onto the staging environment or the UAT environment or the production environment itself, then they are getting the response time very high. So this is very common issue. Scalability issues also refer to the architecture or design of the network on which the client is hosting the application, such that the scalability wise, the server is capable of handling 100 users, but then there is expectation of 300 users which should be entertained through that particularly established architecture. So whenever they are going to scale their application up, then this is causing the failure. And similarly, their APIs or their other architecture is defined in a way that whenever they try to scale to the particular user, then they don't have the expert opinions, so they spend on the wrong directions, and eventually they do not get their objective after spending too much. Then there are bottlenecks, such that there is a checkout point now onto the application. Every user from different region is coming to the same checkout page that has been bombarded during the sale hours or sale days. So there are like on average 100 users which are coming to the checkout at the particular time. But once there is a sale season, then there are 5,000 users which are coming to that point, and eventually that is creating a bottleneck for the application, and users are getting stuck there. Then there are speed issues, of course, that is related to the network or internet or bandwidth. That those are like very easily resolvable, but it didn't get any client's attention at first before we pointed that out. Then there are resource utilizations. Sometimes they have bigger server memory, but they don't have that much kind of bandwidth available. So the bigger server memory is never utilized as per its maximum capability. And they came across to the consultants that we have spent so much, our architecture is best, we have applied the load balancers, but they are not utilizing their resources very well. So this is how performance testing help us in finding out these issues and also finding out the areas of these issues, so that we pinpoint those areas into our reports and present that to the clients, and they get the things sorted out within hours instead of spending the months. So this is where AlphaBolt might help you and your application to get that meet the objectives and goals which you have expected from your application and to the target market on which you're going to release. So this is pretty much it from my side. Now I will hand over to Judd to further conclude this. Thank you so much for your time.
Thanks, Sohaib. Thought we'd do another slide here and do a quick poll. We're just looking to get a better understanding of what some of the problems that you're currently experiencing with your web page. Yeah, These are pretty common: response time issues, speed issues, resource utilization. For those of you that shared none, hey, thanks for joining. I don't know if we can help you out. Okay, I'm going to go ahead and share the results with you. So it looks like speed issue is the number one issue that it seems that we have across the board here. Zoeb talked about, you know, there could be several factors that we could hop in and take a look to help you out, to get you a better understanding as to what's going on. You know, if you did like what you've seen here and want to talk to us, we'd love to have the ability to do that. Alrighty then. Doesn't look like anybody has any questions. If you do want to talk to us, please feel free to reach out. You can reach out to us at sales@alphabolt.com. We'd be happy to set up a free workshop where we could pull Zoeb and Humayun on a call to discuss some of the problems that you're facing with your website and how we can work to improve that performance and get you the functionality that you're looking for, so you're not losing those clients. You know, that is, your website's not timing out and people are leaving things in carts and, you know, carts are abandoned. You know, our goal is to help you do business as well as you possibly can. And, you know, one of your biggest team members is your website to execute on sales. So we'd love to have the ability to talk to you. Again, email us at sales@alphabolt. You can call our sales number at 909-979-1425. Or if you're in the San Diego area, feel free to drop by. Our address is 2011 Palomar Airport Road. We're in Suite 305. That's in Carlsbad. So we'd love to hear from you. Pick one of the three options to get a hold of us, and hopefully we'll hear from you soon. And good luck with your website going forward. Have a great day. Bye-bye.